do the presentation, Advanced SQL Injection in Oracle Databases. Well, this is what we are going to see. First, an introduction to the Oracle Database Server. We will then focus to the SQL injection attacks, how to exploit them. We will see some examples. After that, we will see buffer overflow attacks with some examples also, and remote attacks using web applications connected to an Oracle database server. Then we will see the conclusions. Well, there is something that distinct the Oracle database server in comparison with other database servers, and it is that it's the most complete featured database server. For example, it has the most extensive capability with the triggers and also the most complete support for multimedia databases. All of this has a trade-off, and is that it is a very big software with many features that can have security bugs. And not only that, also many ways in that the security bugs can be exploited. There are a big number of packages, procedures, and functions installed by default. There we can see the numbers of procedures and packages in the two versions of Oracle, and how many are available to normal users. Also, this product is available in many platforms. That's why sometimes there are a lot of time that the vendor takes to release the patches. Well, the ways in that an Oracle database server can be hacked can be divided in two groups. When the attacker is not connected directly to the database server, and when the attacker is connected in the database server as a normal user. If the attacker doesn't have a connection to the database server, for example, in the case of a web application user, the attacks that he can do is SQL injection attacks. With this, he can inject SQL commands, exploit buffer overflows of some packages that are installed by default in the database server, and the output can be retrieved, can be redirected using the networking packages such as UTL HTTP or UTL TCP. If the attacker has connection to the database, the attacks that can be done are SQL injections, buffer overflows. The output can be viewed in the screen. I have reported near 100 vulnerabilities to Oracle. And do you know how many have been fixed by the last July critical patch update? Just one. And they fixed it only in version 10. They didn't fix it in previous releases because the development team neglected to do the fixes for previous releases. At this speed, it seems that the releases will get obsolete before they finish patching the software. But now we will focus in SQL injections attacks in Oracle. It can be divided in two groups. First, when the attacker is connected directly to the database as a database user, it can be used to elevate privileges or to impersonate another user. This risk exists when the procedure is not defined with the keyword out ID current user. So the procedure executes with the privilege of the owner. When the attacker doesn't have connection to the database, For example, if it is a web application user, can be used, a SQL injection attack can be used to execute SQL statements directly in the database, or to exploit a buffer overflow, that there are many in the standard packages of Oracle. Depending on where the SQL injection vulnerability is found, it can be divided in two groups. When the SQL injection vulnerability is in an anonymous PL/SQL block, and when it is in a single PL/SQL statement. When it is in an anonymous PL/SQL block, the block start with begin and end, and can be used to execute multiple SQL statements. This is the most dangerous vulnerabilities because there are no restrictions in what the attacker can do. It can execute selects or data manipulation or data definition statements. For example, there is an example of a code vulnerable to SQL injection in an anonymous PL/SQL block. You can see there is a begin and an end. It is a dynamically generated PL/SQL code. If the vulnerability is found in a single PL/SQL statement, the attacker can't use a semicolon to inject more SQL commands. So it is very restricted in what he can do. There is an example of a vulnerable code, a declaration of a cursor. Well, we will focus on SQL injection in single PL/SQL statement because the anonymous PL/SQL block is very easily exploitable. The attacker we will see this attack creating a user-defined function. So we can execute more than one command, not only using the same statement that is vulnerable. We will inject a function so the attacker can insert multiple SQL statements. But there is a limitation. Well, first the attacker must have the create function privilege, so he can create the attacker-defined function with a malicious code, and also there are some limitations in the statement that can be executed in the function. If the vulnerability is in a select, only selects can be injected in the function, and you can never execute data definition statements. Why is this limitation? We will see an example. There is the my function is an example of an attacker-defined function that the attacker used in an exploit of the drop subscription vulnerable function of the DBMS CDC subscribe. This was the one that Oracle tried to fix in the April critical patch update, and because of bugs, the fix didn't get. So this throws an error because the vulnerability in the drop subscription function is in a select statement, and we are trying to do an insert. So we get they cannot perform DML operation inside the query error. Also, if we would have tried a DDL statement, we also get another error. This is because the execution of the attacker-defined function is inside the transaction context of the vulnerable PL/SQL statement. It is a nested transaction. We will now see the autonomous transactions in Oracle that we will see how can we use this to avoid those problems. The compiler directive pragma autonomous transaction allows to define a transaction as autonomous, completely independent of the transaction where the SQL vulnerable code is. It is not the same as a nested transaction. It has a different transaction context. That's why you must do a commit to avoid an error. So how can we do the attacker-defined function so that we can execute any SQL statement? We defined that function with the pragma autonomous transaction compiler directive. So we inject the code we put the code in that function, and we can execute any SQL statement. So as a conclusion, we can say that if the attacker can create or modify a function, any SQL injection vulnerability in a select, insert, update, or delete can be used to get full DBA privilege. We will now see some examples. All of these are vulnerabilities in Oracle standard procedures in single SQL statements. The procedures have execute privileges granted to public, so any user can execute them. These SQL injection issues have been fixed in the critical patch update of April. If you do all the workarounds that Oracle say you have to do because of the buggy patch. Well, now we will see an example how a normal user can become the sys user, changing his password. First, the attacker, in this case the user's code, creates one function to change the password of the sys user and first to save the hash of the password so he can restore it later, and then change the sys password. The other function, restore password, is used to restore the password value to its original. Well, we will see. Here we create the two functions. And the table where we store the original password hash. And this is the exploit where we inject a concatenation of the function. Now we try to connect as the sys user with the new PSW password. And we get connected. If we want to restore the password, we use the other function that we create and execute the exploit. So now we will not be able to connect with the new PSW password, but the old password that was 5 will work okay. Well, the Oracle database server allows to create a Java storage procedures that can execute Java code. This is useful for an attacker because the Java language has a lot of features like networking and operating system commands. To do this, the attacker can create a function that first create the Java source with the method that contains the malicious code, then publish the method with stored procedures that calls the Java method, and then grant execute on this method to the attacker. So now we will see an example of an exploit to execute operating system commands. To do this, we create the Java storage procedures that call the get runtime exec Java function, redirect the output to a file, and then read the file and print it to the output. So we will get the output of the command. Then we publish the Java class creating a storage procedure and grant the execute privilege on this procedure so we can execute operating system commands. By default, the Java console output is redirected to a file. So to view the output, we must execute those two commands, the set server output on and the call dbms Java set output. We will see an example. So now I create the SQL function that contains the code to create the Java source and publish it and create the storage procedure that executes it. Then I execute this function with SQL injection, so it executes with privilege of the sys user. And now to see the output, to execute this. And now we can use the proc execute operating system procedure to execute a command in the server. For example, dir. And we get the output. Also, it can be done another exploit that upload a file to the server, similar to the previous one, using the JavaNet classes, and well, publishing the procedure and granting execute privilege on it. Now we will see a method that will allow us to view the vulnerable code of the Oracle packages. For that, we will use the vSQL text view. That is a view that shows the SQL statements in the Oracle shared pool. There we can see an example of a query that can show you this information. In the set pattern, we can put something that we use in the exploit, so that we will get where the exploit, where code that exploit was executed. We can use other views like vSQL area, vSession, and vProcess to know what user execute the SQL statement. This view can only be used by DBAs. For example, in the vulnerability in the drop subscription procedure, if we execute the query we have just seen, we can get this. In red is the exploit that was executed as the user's code, and then in blue we can view the vulnerable PL/SQL code inside the Oracle package. We can see that it is in a select, and in the where clause was used the parameter directly. With concatenation, we can execute the attacker-defined function. That vulnerability is the result of a PL/SQL statement similar to the one that is shown there. For example, a cursor definition that concatenates a parameter that was passed to the procedure. That should have been something like what is shown on the bottom, that use bind variables. Well, now we will see all the other functions vulnerability that we have seen were executed with the privilege of the owner, in that case the sys user. Now we will see vulnerabilities, SQL injection vulnerabilities that execute with the privilege of the caller. At first sight we might think that this is not useful because we didn't do any privilege escalation. But if this vulnerability is in an anonymous PL/SQL block, it can be useful for two things for an attacker. To get around the need to create a function and use this vulnerability to inject SQL statements. As it is an anonymous PL/SQL block, we can define that block as autonomous. Another thing that can be done with these vulnerabilities is, in the case of a web application, to execute any SQL statement, even if the vulnerability is in a select, and as we know, in Oracle you can't inject more SQL statements because a semicolon is not allowed. Well, we will see now the vulnerability that exists in the DBMS metadata package, the get prepost table act function. So we submit that query, and if we analyze it with the vSQL text view as it's shown there, we can see that this vulnerability has some features, like it has a begin and an end, as we can see in the third and fourth row of the result. The first two are the exploit, and the third and the fourth are the vulnerable code that executes, as we can see, as the same user that calls it, but it has a begin and end. So we can conclude that that function is vulnerable to SQL injection in a PL/SQL anonymous block that executes with the privilege of the caller. Well, now we will see how can we define an autonomous transactions inside that PL/SQL block. To do that, we can use the execute immediate statement and declare generate a sub PL/SQL block that has declared the pragma autonomous transaction keyword. So if we call in the second parameter of the pre-table function with the blue code that is shown first, we can define an autonomous transaction function, a sub-PL/SQL block, not a function, but it will have the same use like the user-defined function. So this can be used to get around the need to create a function and use this vulnerability to execute the malicious code. There is an example that combines a vulnerability in the push window procedure and now it doesn't inject a user-defined function, but it uses the vulnerability in the getPrePostTableAct function, so it can define an autonomous transaction and execute any SQL statement. We will see an example of this. But here we're connected. As the Scott user, as we can see, we don't have DBA privilege. We now will use this exploit that use two SQL injection vulnerabilities. One in the push window procedure and the other in the getPrePostTableAct function. We now will reconnect and we now have DBA access. Well, if we analyze this exploit with the SQL view, we can view inside the database what statements were executed. Here we will see better. In the first statement is the exploit, where we call the push window procedure with that parameter in blue that generates the execution of the second statement, that is a select in the CDC subscribers table that use the first parameter of the push window procedure without sanitization. So it generates a concatenation of an empty string and a call to the getPrePostTableAct function. This generates the third statement that, as we can see, is an anonymous PL/SQL block that executes the pre-table, a call to the pre-table procedure, but we insert more statements, like the execute statement, the execute immediate, that generates an anonymous PL/SQL block that contains the malicious code. The third statement generates the execution of the fourth, that is the anonymous PL/SQL block in an autonomous transaction. The fifth is the malicious code that finally gets executed. All of this is the same as the result of that query after executing the exploit. So we can conclude that using a SQL injection vulnerability in a function defined with the auth ID current user and in an anonymous PL/SQL block, an attacker can use any other SQL injection vulnerability in a select, insert, update, or delete to get full DBA privilege. Well, there it is an example of how the vulnerability in an anonymous PL/SQL block that executes with the privilege of the caller can be used in a web application to execute any SQL statement. There, the table lamp ASP web page has a vulnerable parameter that is search. In that case, the function allows the get prepost table act vulnerability allows to execute any SQL statement. If we just use the vulnerability in the search parameter, we maybe can't execute anything more than an union or something like something related to the statement where the SQL injection is, not any other SQL statement like in this exploit. So how can we protect from SQL injection vulnerabilities? As we have seen, there are a lot of vulnerable packages in the Oracle default installation. So to remove the execute privilege on the Oracle standard packages is a very good measure. Also, the create any procedure and alter any procedure privilege should be granted only to trusted users. Also, as if the user owns a function, he can modify it. Only trusted users should own functions. The resource role includes the create any procedure privilege, so it should also be granted to trusted users. Whenever it is possible, it is a good thing to do to define the stored procedures with the auth ID current user keyword that is to execute the procedure with the privilege of the caller. It is not the default behavior when we create a procedure in Oracle. When we need to use dynamic SQL, we should be very careful and always try to validate the parameters or use bind variables, even on functions defined with auth ID current user keyword, because as we have seen, it is also dangerous. Well, now we will see some buffer overflows attacks in Oracle. It allows to execute arbitrary code on the server. It can be exploited by normal users or through SQL injection by web application users. There are many Oracle standard storage procedures that have buffer overflow bugs. So, using buffer overflow, an attacker can execute operating system commands, for example, and create an operating system administrator user. The exploit I will show here now is in the SDO codesize Oracle standard function. For example, we now will see how to create a bind shell with this vulnerability. Well, this exploit creates a bind shell on port 444 that we can now use it to get a remote shell on the server, on the Oracle server. Well, now we can see I am in the Windows 2000 server, that is where the VMware is executing with the Oracle database server. Here I can execute any command on the server. Also, with exploiting a buffer overflow in Oracle, it is possible to execute SQL statement as the sysdba user. To do this, for example, this is in Windows, we can use the echo command to create a script file. With this script file, we can create a user, a database user, and then we can call the SQL Plus application to execute the script. Well, there is a way that we can detect some buffer overflows attack, but it is difficult. It can't be detected always. But one thing that can be done is to review the dump files that Oracle generates automatically. For example, one interesting file is the core log file that there we can search for access violation or segmentation fault exceptions, and the code, the injected code may be in the stack dump. So we can review there. But it also can be a bad execution of or a bug in Oracle. It's not always an attack. Also, there is an associated file that can be used where the SQL statements are logged. That is the Ora3.id TRC file, and there we can see what was the SQL statement that the attacker executed. Well, as I said, the Oracle internal errors can also generate these dumps. And there is also some ways that the attacker can avoid generating those files, such when the process dies, or if the attacker calls the exit thread function. Well, now we will see some remote attacks using SQL injection in web applications. In this example, we will use the table lamp ASP a web page vulnerable, this page is an example of a vulnerable web page to SQL injection. It query a table and print the output in the screen. The parameter search is vulnerable to SQL injection. Well, this, as we said before, this vulnerability may seem not very dangerous, but if we can inject a function call, we can do a lot of damage in an Oracle database server. Well, in this example, we're exploiting the same buffer overflow we saw before in the SDO code size function. In this exploit, we execute an operating system command. What we'll see. In the host machine, I am running an ES server that has this table-lemp ASP web page vulnerable to SQL injection that connects to the database, to the Oracle database server running in the VMware box. I execute this exploit. I come here in the VMware box and can see that the dir command was executed to date. Now I generate this file. So, as we can see, SQL injection issues in web applications using Oracle database servers are very dangerous. Using this kind of vulnerabilities, it can be created a worm, a web application worm, that could be very dangerous to the web applications. Because there are many web applications that are vulnerable to SQL injection attacks, and exploiting vulnerabilities in Oracle standard functions, the worm can propagate it. For example, what the worm can do is search for pages, for a web page, and try to exploit all the parameters. So there are some measures that we can take to protect from these threats that is similar to the SQL injection threat. We can revoke execute privilege to Oracle standard packages when are not needed, especially for the public role, that there are many packages that have public access. Or restrict network access to the listener and iSQL Plus services. We drop or change password of default users. This very common measures to take. But there are a lot of Oracle database servers that have the default users enabled. The web applications, we must be sure that are not vulnerable to SQL injection. If we must use dynamic SQL code, we must ensure that the parameters are validated, and or we can use bind variables. Keep the Oracle software up to date with the patches, and we must, a good measure also is to try to upgrade to the last Oracle database server released and patched, because generally the latest patches are what most fixes are included. Well, as a summary, we can say that there we can see the different ways in that an Oracle database server can be hacked. That is, when we have direct connection to the database, we can use buffer overflows in storage procedures or SQL injections that allows the attacker to execute any code on the server in the case of the buffer overflows, or get DBA privilege if we are exploiting a SQL injection. In the case of a remote attacker using the database through a web application, there we can exploit SQL injection. The SQL injection in any statement can be used to exploit buffer overflows, or to do SQL injection in functions defined with execution of the caller or of the definer. Both are dangerous. Well, as a conclusion, we can say that there are many features that are installed by default in Oracle database server, and most of them are never used and represent serious security risks. Those many of the standard processors are vulnerable to buffer overflow or SQL injection issues. With a buffer overflow, we can execute SQL statement using the SQL Plus utility. Well, automatic testing tools can help DBAs with all those checks. Well, these are the reference where I got the information. Well, that's all. Do you have questions? Do you want to see another exploit, an example?
What is the methodology that you use to find SQL injection? And did you go through all 10,000 stored procedures to find them, or
I think the best way is to use, first to know maybe a fuzzer or something like this could help with the many, because there are many procedures. So the fuzzer can be useful to automate the testing, but always you have to test one by one because a fuzzer miss many of the bugs.
The functions you just showed, which of them are, like, when were they patched or are they not patched?
Which?
Some of the functions you're injecting into, are they already patched and what version?
Yes. Well, there it says that in the April patch they fix. Yes. The other that they are used to execute to generate the anonymous PL/SQL block, that one is not fixed yet. But it should be used with another or in a web application, because it doesn't allow to escalate privilege.
Also, you mentioned a lot of these vulnerabilities are being fixed only in release 10 Oracle. What's happening to the 9 and older ones?
Now they are working on the 9, but I don't know why they sometimes they just fix on one release and they don't fix on the previous. Any more questions? Well, that's all. Thank you.